Hello everyone, welcome to day 26th of November Leetcode challenge, and I hope all of you are having a great time. Let's quickly walk through today's question. Today's question is search insert position. In this question we are given a sorted array of distinct integers and a target value. We need to identify the index at which this target value is to be placed. Let's try and understand it by an example. Here the input array that is given to us is 1356 and the target value that is given to us is 5. So where are we going to place this 5? We'll place this 5 at index 2 somewhere between 3 and 5. This point is to be highlighted that we want to look out for the lower index in case there is a matching case. The other possibility could have been between 5 and 6. But we are not considering that index, we are considering index 2 as an answer, which is towards the lower index here, somewhere here. So the updated array would be something like 13556 and you have inserted the new target element at position 2. This is what we need to return, the position at which the insertion is to be made. Without much ado, let's look at the PPT that I have created for this. And also in the question that it is specified that the runtime complexity of this algorithm should be log n. Had this not been there, very basic and naive approach would have been to iterate through the complete array one by one, and as soon as you find the position at which the value of the current element is greater than the target value or equal to the target value, you abort the process and return that index. However, the time complexity of this approach would be linear and we don't want to do that. We are looking for log n complexity. So let's move on to the PPT. Let me just take a pen here. Search, insert, position, Leetcode 35. It's an easy level question on Leetcode and I also feel the same. Also, the question gave you the biggest hint. What was the hint? The array is sorted. So whenever the array is sorted, you have to do a binary search. There is no other way out. Go for the binary search algorithm. Simple and straightforward. Don't think of anything else in this universe. Only put all your money on binary search. So let's start the iteration. We'll do a regular binary search and let's take a slightly different example. The low would be pointing to 0. The high would be pointing to the last element. And what we will do, we'll identify the mid one. Even before, let's discuss the target element. Let's assume that the target element is 2. So 0 plus 5 by 2 gives us 2. And what do we have? The middle element as 2. At mid, the element value is 5. So what do you see? That the middle element 5 happens to be greater than the target element. That means we can safely discard the right part of it. So everything on the right can be safely discarded. And what we will do, we'll update the high pointer to mid. Simple and straightforward binary search that we often use. Let's proceed ahead. Low is pointing to 0, high is pointing to 2. Let's go and find out the middle element. The middle element turns out to be 3. This one. And let's make the comparison. The target value is 2, the middle value is 3. So we can safely ignore all the entries to the right of it. So these can be ignored and high gets updated to 1. So high gets updated to 1. Let's proceed ahead. We have low as 0, high as 1. So let's go and identify the middle element. What is the middle element? Middle element turns out to be 0. And here, what is the value? The value is 1. What is the target value that we are looking for? The target value is 2. So you observe that 1 is lower than the target value, and in such case, what do? We update low to mid plus 1. As a result of which, low gets updated to mid plus 1, which is 1. So now low and high points to the same entry, and we abort the process by virtue of low and high becoming equal, and this becomes our answer, which is nothing but 1, which is in sync. If we insert 2 at the first position, then the complete array will remain sorted. The updated one would be 1, 2, 3, 5, 6, 7, 8, 9, and this is what we need to return. So we return the index where the insertion is to be made. Now let's look at the coding part, and I'll exactly do the same steps as I've talked here. So let's start the iteration. I have taken 2 pointers, low pointing to 0, high pointing to nums.length. While low is less than high, I go and identify the middle element. I check if my element at the mid index happens to be greater than equal to the target element. Why I am saying equal to here? Because we are inclined towards finding the lower index, not the higher index. Therefore, I have taken equal to sign here, and in that case I update high to mid. Otherwise, I update low to mid plus 1. Once I'm out of this loop, I simply return the index where the breaking condition happens, and low will give us the answer. Let's try this up. Accepted 100 times faster. In terms of memory, I don't know, I'm not using any extra memory space, but it says that it is 8% faster or better than other solution, but that's fine. This brings me to the end of today's session. I hope you enjoyed it. If you did, please don't forget to like, share, and subscribe to the channel. Thanks for viewing it. Have a great day ahead and stay tuned for more updates from Coding Decoded. I'll see you tomorrow with another fresh question. But till then, goodbye.